The big thing you've got to remember for graphs of absolute values, no matter like we did yesterday, is that the graphs are always V-shaped. And what we looked at yesterday was that, with these graphs, you may flip it upside down, you might move it left or right, you could stretch it, you could shrink it, all these different things that you're going to do, but basically everything is going to be V-shaped. Good. And to graph these equations that we're going to work with, you basically need two things. Okay. The first most important thing that you need today, and this will be the exact same thing that we'll do with the next thing we've got coming up, because the next topic we're looking at, again, is this the exact same thing as absolute value, but instead of being a V-shaped graph, it's going to be a U-shaped graph. And it's going to have a lot of these same characteristics, a lot of these same qualities with it. But the most important thing you have to have is the vertex. Okay. And when we're talking about the vertex, that's the point on the V that's here. So where you've got these two, basically it's where you've got two rays that are drawn when you draw out the V shape that's here. So it's the point of the V where your two rays meet together at that point right there. Okay, so again, that's your vertex. It's always that, because basically, if you draw an absolute value, it's always you start at one point, you draw a ray up to the right, you draw another ray up and to the left. If it was negative, you'd start here and draw one down to the right and one down to the left. All right, second thing you have to have, and this is not anything that you'll find in a book anywhere because of the way I'm going to say it here. It's the kind of slope, because it's not slope, but it's a lot like slope of the way this thing is set up. Um, it's your coefficient. It's the number in front of x. And that's one thing we were looking at yesterday. That we've got the coefficient, which is the number that you're multiplying with x, and then you've got the constant, which is a number that you add or subtract with the x. And so the kind of slope, just like when we're doing y equals mx plus b, that we were doing when we were graphing everything. Y'all don't have to write this down, but just going back to this one. Just like when we were doing y equals mx plus b, how this was our slope. And again, it's the number that's times x. Same thing when we do absolute value. If it's some number times the absolute value of x, it's not exactly slope, but it's still kind of like slope the way this thing is set up. And we'll talk about what that is. Why it's kind of like slope, basically is this, is that you move up and left from the vertex. So you get 1 point. Okay. And if we were doing a slope, you would move, 1 point left, 1 point right, whatever you can do. This time you have to do it twice. You got to move 1 point up and left from the vertex to get 1 point and move up and right from the vertex. To get another point. Okay, so if it's positive, now again, if it's negative, instead of going up, then you have to go down. Just like slope, if it's positive slope, you would go up. Negative slope, same thing, you go down. So in this case, still the same way. You're still going to move up if it's positive. You're going to go down if it's negative. So again, that's where it's kind of going on that direction as we go through those. Okay, so again, we're going to find the vertex, figure out where that point is, and then we're going to either go up and right and left if it's positive. If it's negative, then we're going to go down and right and then down and left from the vertex. Okay, and then here's the last little thing they'll throw at you, and then we'll start getting ready for some graphs here, is standard form. So just like we do, when we were graphing, we did y equals mx plus b, with standard form for what we're doing. Same thing with this one. There's a standard form. That was standard form for graphs if we were going to put it in y equals mx plus b form, which is kind of like standard form. If we're going to plot points, this one's going to have the same thing when it does absolute value. It's y equals a times x minus h plus k. Okay. Now, and what we're doing now, we already kind of looked at this yesterday because we were talking about this a little bit yesterday. That this number on the inside tells you how much you're going to move left and right in the opposite direction. This number on the outside tells you how much you're going to move in the vertical direction. And that's kind of basically what you have for this part. So this is what we need here. The a value that's here, again, that's your kind of slope. Because it's kind of like slope, but it's still different slope. It's not exactly slope, but it's kind of along those same lines. Okay, and then your h and your k that's here. Now, just like yesterday, we went opposite direction. So when you pull this number out, you're going to change the sign. So if it's negative h here, we're going to make it a positive h here. And whatever that sign is, it stays the same. This hk that's here, that's your vertex. So whenever you have to start with the vertex, they give you the numbers right here. So that's going to tell you always where to start when you go through this thing. All right, and to me, one thing they missed out on that, and to me, I don't know who came up with this form, but they should have made it easy on this part of it. But h is your horizontal movement. So, when they talk about the h and the k that's in this thing, h is your horizontal movement. And to me, they missed like a perfect opportunity, because if this is h for horizontal, well, the k value that's here is this. To me, I don't know who came up with the formula, but it should have been this way. If this is the vertical movement, then this thing should, instead of being k, it should have been v. So it should have been h plus v to let you know that this should be like hv, because that would be your vertical movement. Who decided to put k in there? I don't know. Don't know why they used k in that case, but they did. So.
I mean, it kind of looks like a V with a little line at it.
Yeah, it kind of does. Yeah, because you got the V shape there with the stand on it, so it won't fall over. So, yeah. I mean, but to me, if H is horizontal, then it should be like HV. It should be like horizontal vertical. That way, it would kind of make more sense as you go through this one. Now remember, when you get the H on this, remember that's still your opposite horizontal movement. So still your horizontal movement, but we're still kind of going, it's the opposite direction from what you want back here. Because again, it's going to be, if it's minus back here, it's going to be positive there. What do you think about that? Again, the H stands for horizontal movement. To me, that if that was V, that would be vertical movement, but they didn't make it that way. So that's just, just what it is. All right, so here's what we're going to do. We're going to take that formula. We're going to flip over to the graph side of this paper, and we're just going to graph some of these so you can kind of see what it looks like. Because yesterday, again, we talked about a lot of this. We didn't do a whole lot of graphs yesterday. Mostly just kind of looked at them. This part, we're actually going to graph these today so you can see exactly what's going on with this thing. All right, so for the very first one, we're going to do this. And again, here's our standard form back up here. All right, and the very first one we're going to graph is that. Okay, and there's a bunch of different things I can ask you for on these, not as much as it was like on that last test where we did, the increasing and the decreasing and the positive and the negative and all the intercepts and all those. This one, there's not going to be as much stuff. They could throw a few things at you, but not 10 things like we did on some of those questions on the last test. But we'll get what we can get out of it first here. This is your H, this is your K. So when I ask you to find the vertex, again, all you have to do is just change this sign on the inside because it's the opposite horizontal direction. So it's 2, 4, and that's your vertex. Okay, so when we go to graph this one, we're going to go to 2, 1, 2, 3, 4. Put a dot there. And again, what we've got to have from that point is the A value, which in this case, there's not a number here, so that means your A value is 1. But again, if we treat it like slope, it needs to be a fraction. So if it's not a fraction, we're just going to put it over 1. So from this point, we're going to go up 1 and over 1 to the right side, then up 1 over 1 to the left side, and there is your V shape. And if you're going, well, that seems pretty easy, that's how easy it's going to be. There's not really anything tricky on these when it comes off of it. If that makes sense of how we're moving that part, they don't really do anything different when it comes into this thing. All right, now one little detail we'll add on some of these, just to make sure we've still got some practice on this, is we are going to ask you about domain and range here. I'm going to put that one over here on this side. All right, so we're graphing this one. How far does it point to the left? Goes to infinity, right? How far to the right? Infinity. So the good news on this one is if they ever ask you for domain, it's always negative infinity to infinity because it's always going to be a V shape. So it's always going to go forever to the left and always forever to the right. So this part never changes. So, if you want to up here at the top, you can put that domain is always negative infinity to infinity. And a lot of times on these, that I think some of the questions, they don't even ask you about the domain because it's always negative infinity to infinity. And once you graph 2 or 3 of these, you're like, okay, it's the same answer every time. Why do they keep asking? A lot of times they want to ask you for domain because it's the same every single time. Now the range is the one that's going to change a little bit. Oh, let me go back to the last test question on this one too. All right, if this is our vertex right here, is that a maximum point or a minimum point? All right, so we know that's a minimum. All right, so that's one good other thing to have there. Okay, so if that's the minimum, that's as low as we can go, and that point's at 2, 3, right? So if we're talking about range, that's a y value, so that's going to start at 3. And it goes up forever, so that's 3 to infinity. And so on the range on these, you do get to box that number in. So anytime we're doing range, whatever number you're going to use for your y value from here. Wait, I'm sorry, that's 4. My bad. Can't count. because that's this same number that's here that's going to go there. My bad. So whatever that y value is that's here, that's going to start off your range there and go from there. Okay, seem like it's okay? All right, let's do another one. All right, so for this one, let's do absolute value of x minus 3. Okay, so for the vertex, again, whatever's on the inside, there's nothing on the inside, so that means that's going to be 0. We've got the negative 3 on the outside, so there's our vertex. So 0, negative 3 would put us at 1, 2, 3 right there. Okay, we don't, again, another one on this one. We don't have the a value, so we know in that case your a value would be 1. But again, it's still kind of like slope, so still write it as a fraction, so it's 1 over 1. So from here, we get to go up 1 over 1 to the right side, up 1 over 1 to the left side, and then that gives us that V shape that goes something like that. All right, same question. Vertex, is that a maximum or minimum point? That's minimum. It's at the bottom, so we know that's going to be a minimum point. Okay, domain, again, it's never going to change. It's still going to be negative infinity to infinity every single time. The range, though, is going to change a little bit. So if that's the minimum, we're going to start at negative 3, and it goes up forever, so it's negative 3 to infinity. Okay, so, and again, hopefully you're kind of getting that catch that, okay, if I've got the vertex, then I'm going to use this y value in the vertex in my range. Like over here, the y value is 4. We started with 4 here. This y value of the vertex was negative 3. We started with the range there at negative 3. So it's always going to be that whatever that number is in the vertex is the y value. It's going to be the same thing you're going to have there. And that's going to work every single time. Back here it was a 4, and then had 4 there. Okay, so both of those were positive numbers. Let's throw one at you that's a negative number, just to see how it looks. So we got y equals negative 2 times the absolute value of x. Okay, nothing back here. So if there's nothing there, it means it's 0, 0. Because there's no left or right number, there's no up or down number, so that one we're not going to move away from the axis, from either one of the axes. We're going to start at the origin there at 0, 0. For that one, our a value is negative 2. But again, still want it to be like a fraction, so we're going to say negative 2 over 1. So we're going to go down 2 over 1 to the right side, down 2 over 1 to the left side. Okay, so where's the vertex now? Top or bottom? That's at the top. If it's at the top, that means the vertex is a max. All right, again, domain, negative infinity to infinity. The range, again, now we know we're going to use the y value, but it's if we go like the y axis here, it's going down forever because they're both headed down. So the bottom, the low number is going to be negative infinity. We're going to stop at the top at 0. So that'd be negative infinity to 0 for the range. So if it's the max, it's at the top. If it's the minimum, it's at the bottom. And that's the whole thing they're trying to get you to see in this one. If you know the vertex is the minimum, that means you're going to start with that number. If the vertex is a maximum, you're going to end with that number that's the y value that's there. Okay, so and it'll be that way every single time. So if it's the max, it's the last number. If that was minimum, that would be the first number. All right, one more. Everybody good there? Everybody still writing that one down? So go 1/3 times absolute value of x plus 1 minus 2. Okay, so we got an a value of 1/3. So we got a plus 1. So when we write the vertex, that's -1. Again, the one on the outside doesn't change. So there's our vertex at -1, -2. Okay, so -1, -2 would put us there. Okay, and again, a value is kind of like slope. So from this point, we're going to go up 1 and over 1, 2, 3 to the right side. Start back the vertex again. We're going to go up 1 and then 1, 2, 3 to the left. We don't get to go to the front or the back. We don't get to dip, but in that case, that's it. Just go right and left. Okay, again, vertex. What is it now? Max or min? Yep, at the bottom, so it's minimum. Domain and range. Again, domain's never going to change. It's still -infinity to infinity. The range, because it's the minimum point, we're going to start with that y value of -2. And it's going to go to infinity. So again, if it's the minimum, we start with the y value. If it's maximum, you end with that y value. So there we go. Okay, and that's one of those things that just as you practice this more, that'll get easier to drag that number into the range. It's just we just got to kind of get used to it there. Now the other thing we could do for this one, if the a value is 1/3, is that a stretch or a shrink? Anybody remember yesterday? Yeah, there we go. So that would be a shrink. So if they ask you, what happened with this scale of 1/3, what's that going to do? Is it going to stretch it or shrink it because it's 1/3? That would be a shrink. This one, if we backed up over here, the negative made it a reflection, but then the 2 would make it a stretch because now it's a little bit skinnier. Because if we actually went back and graphed just absolute value of x and it was negative, it would look more like this. So then you can see that it's a little bit skinnier. It's in tighter than the normal graph. So again, this one would be a stretch where this one would be a shrink because of the number that's there. And that one you can see. Now again, when you think shrink in this case, that means it's going to go out wide. Again, sometimes they don't say shrink. Sometimes they say compress. Because again, it's almost like they're pushing down on this V. And as you push down on it, it's going to make it go wider. It's like you're squishing it almost if you do that. Okay. Oh, and about the only other thing I can think of that might sneak into a problem like this is we might sneak in a less than or a greater than. So if you've got room, you can put it here at the bottom. If you've got room where we write notes on the back, you can put on the back here. I'll just do just a quick one here real quick. If it's an inequality where you got less thans and greater thans, you still basically do the exact same thing. You still find your vertex the exact same way. Number on the inside, change the sign. Number on the outside stays the same. A value would still be 1 because there's, technically a 1 that would be there. So again, make it into a fraction so it's 1 over 1. And we're just going to kind of rough sketch this one. Okay, so if we go to 3, 2 over 3 up 2, that would put us right there. So there's our vertex. And again, slope is 1 over 1. So we're going to go up 1 over 1 this way, up 1 over 1 that way. Now, here's the difference with these. Because of the less than or the greater than part on this one. When you draw this one, because it's just greater than, that's going to be dashed. Where if it had the bar underneath it, we'd make it solid. There's no bar, so it's going to be a dashed line. Okay, and then we also are going to have to shade. So if it's greater, that's where you're going to shade up. You're like, well, how do I know where to pick from? Doesn't matter. Again, anywhere on the line that you've got, anywhere on this V-shaped line, you start on the line and you're going to shade in the up direction. So no matter where you start, you're going to do something like that. So basically, if you had a shade, you'd have to shade everything inside there.